Hello, and welcome to a digital statistics lecture for Salt Lake Community College. In this video, we're going to be talking about section 9.3 for Math 1040, putting it together, which procedure should I use? Now, I'll say that this video is going to be incredibly short because section 9.3 is kind of just a review over sections 9.1 and 9.2. So we only really have one page here in the guided notes that we're going to go through, and I don't really expect this video to take too terribly long, but I still wanted to address this. All right, so this will talk about what are the procedures we're going to use for confidence intervals. All right, so we have a couple different parameters of interest we tend to look at, either calculating the mean, mu, or calculating the parameter p. Note that that's just p because that's the population parameter, not p hat, which is what you get from a sample. So those are the two things that we're going to try to calculate. All right, now if you have a sample size that's less than 30 first, if you have a sample size that's less than 30 and you don't know that it's normal, then that means that you have no procedure. The reason is because what you have done is now U-R-E. Okay, no procedure. You have no procedure here because you have failed the central limit theorem. The central limit theorem states that you either have to have a sample size bigger than or equal to 30, or you need to know that the distribution itself for the population is normal. If you don't know either of those, then that means that you cannot work with confidence intervals. And it will also be true with what we talk about in Chapter 10 with hypothesis testing. So checking these conditions are really important. However, if you have a lack of sample, but you do have a normal distribution, then that means that you can run this. Or if you simply have a big enough sample, then you can run this. And what we're going to run for mean is going to be t-interval. That being located in stats over in the test section. So that'll be number 8 on most calculators. If you were working with a proportion instead, we have to make sure np1 minus p is greater than or equal to 10. We don't necessarily need to know if it's normal, we just need to meet that and the other conditions. If we have that done, then we can run our procedure for proportions, which is not t-interval. We run instead 1 prop z int. And that should be on technically number 11, which they have labeled as A. So yeah, I know A is not a number, but number A basically on the listing there. That's what we're going to have to run there. Make sure you don't run 1 prop z test. That's something different. We'll talk about that in Chapter 10. Make sure you don't run 2 prop z int. That's also something different. We'll talk about that in Chapter 11. These are very particular tests. Make sure you know which one is which, and it should make your life easier. So what we're going to talk about on the examples down here is looking at the situation, trying to figure which one is going to be appropriate. T-interval or 1 prop z int. Okay. So first, construct a 95% confidence interval for the proportion. We are done. Once I see proportion, I know what I'm working with. This is going to be 1 prop z int. So this is basically looking at the description, trying to figure out what kind of parameter I'm trying to estimate. What is the 90% confidence interval for the mean? Again, done. I don't even need to know the context and know what I'm working with. This is going to be t-interval. Again, assuming that I meet the conditions. Okay. What percent of Americans own their own homes? So this one doesn't say a proportion or mean directly, but it does kind of say it indirectly. Percent. Percent is going to be the same way of analyzing things as proportions. So this is going to be yet again 1 prop z int. The next one, number 4, the weight in grams of M&M candies which are normally distributed. All right, so we have values here. The data is presented to us. We're looking at weight. We're not looking for how many have equality or the percentage of them. We're looking at just a actual value. That means that we're working with t-interval. Now, if you look at what's provided, we also notice we don't have that much. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 in our sample, so n is equal to 8. That's far too low, so we would fail the central limit theorem. However, we know that it's normally distributed. Since we know that it's normally distributed, the sample size is not exactly important. So, as long as we know the population is normal, the sample can be any size, but the more the better. Human gestation period, 95% confidence. We have n is 42, sample average is 268.8 days, and sample standard deviation is 16 days. This is going to be another t interval. We have the average here. What we're also looking at is just gestation period. We're not looking for like percentage or proportion of things. This is just t interval. Note that with t interval in the previous one, though, we have the data. So this is t interval with data, whereas here this is t interval with stats. Because in the previous case, the data was presented, the actual list, whereas in this case, we actually have the statistics. We have the mean, the standard deviation, the sample size, all that's provided for us. We also note that the sample size is 42, which is good. We met the central limit theorem. Just like in the previous case, we failed, but we had it normal, so we didn't care. Here, it didn't say that the human gestation period is normally distributed, but with the sample size bigger than 30, we meet the central limit theorem, so everything is good. Lastly, of 1,201 individuals surveyed, 62 lived in neighborhoods with unacceptable levels of carbon monoxide, estimated with 9% level of confidence. Here, the thing that we're trying to talk about is whether they live in neighborhoods with unacceptable levels of carbon monoxide, or if they don't live in neighborhoods with unacceptable levels of carbon monoxide. That means this is a qualitative variable. We're looking at one or the other, a yes or a no situation. Furthermore, we have a number of the total that have this quality. This is a proportion, and therefore we're going to work with this with one prop z int. That's what we would need to solve this. However, what we should check, though, is if this meets the one condition, or the one condition we can check with this information provided, which is np1 minus p. P or p hat here, that's going to be 62 out of 1,201. That's going to be our p hat, so we can solve that. Get 62 divided by 1,201. And we get about 5%, so 5.16%, or 0.0516. Now to check that, we're going to do 1,201 times 0.0516 times 1 minus 0.0516. If this doesn't if this is not greater than or equal to 10, then we are not good. We can't use one prop z int, but I'm pretty sure this is going to be okay. So 1,201 times 0.0516 times 1 minus 0.0516. Pretty sure this is going to be okay. We get 58.7 or 59. So this is 59, which is more than 10. So our condition is met. All right. So this was basically just looking at questions and trying to figure out what process we would use in order to solve these, and also keeping in mind the conditions. Conditions are going to be incredibly important, so make sure you have those down. Make sure that you know that for a mean, scroll up here, if you're calculating for a mean, you have three conditions. You want to know simple random sample, you want to know that the sample is less than 5% of the population, and you want to know the central limit theorem, which is either you have a big enough sample or you know it's normal. If you're working with instead a proportion, then you want to know simple random sample, the sample is less than 5% of the population. Those are the same two conditions. And you also want to know this NP1 minus P greater than or equal to 10 bit. So each of them have three conditions you need to check. Make sure you have those down. If they are not met, then you should not do these processes. So always focus on that. Or at least address it. Anyway, that's what I wanted to talk about in this section. I hope this helped. From here, go ahead and try 9.3 if you have not already. This is the end of Chapter 9, so you should be good to go through all of Chapter 9 and finish up all the homework there. I hope this helped, and I hope you have a good day.